Hello, friends. How are you doing today? I hope everything is great. Okay, today we will have a seminar on strategies of managing legacy code. Let's figure out how to ensure business continuity and future-proof systems. Okay, very good, friends. The seminar is presented by Svitla Systems, USA. Okay, let's move on. Okay, you can see the agenda of our seminar. We will discuss what legacy code is. Okay, we will also cover all the challenges of legacy code and future trends in legacy code management. Great, I hope you will find it interesting and feel free to ask your questions at the end of the seminar. Okay, guys, now about our author. Well, Kostyantyn Kharchenko, Chief Technical Architect at Svitla Systems, PhD. Dr. Kharchenko leads the technical department as our IT expert and sets up the strategy and process standards. Kostyantyn has over 30 years of experience in complex software systems development and design. Let's take a look at what legacy code is. Okay. Is 30-year-old code legacy or not? Well, guys, can 2-year-old code be considered legacy code? As defined, legacy code is old computer source code that is no longer supported on standard hardware and environments and is a code base that is in some respect obsolete or supporting something obsolete. Okay. But we should remember that legacy might refer to the system overall, not just the code. Great. Also, we should remember about the legacy of the testing environment when we cannot reproduce testing parameters or test cases. And remember about old deployment tools that could also be obsolete. Okay, but why should we pay so much attention to legacy code? Here on the slide, you can see how much money companies need to spend on supporting legacy systems. Too much money, right? Well, 75% of budget allocation for support, instead of creating something new and progressive, tricky. Too much effort to support outdated systems, isn't it? Okay. Heh. Well, we often don't realize that legacy systems are all around us. Here are some well-known examples. Let's take a quick look. Do you know, why does the Linux terminal window have a default size of 25 by 80 characters? So simple, right? The answer is quite curious, because of punch cards. The first terminal display needed to support code that was entered with punch cards. Okay, funny. Why is another standard for terminals 132 by 66? You will never believe it. Well, it's because of line printer perforated paper. Okay, great. Next example. Mrs. Hamilton sent a man to the moon. She did an excellent job. Here is the printed code that she created for the spacecraft. It was developed in assembler for the specific computers inside the spacecraft. She brought her young daughter to the lab with her. One day, as her daughter played with a simulator keyboard, she inadvertently crashed the simulator. This incident was a light bulb moment for Hamilton, yeah, underscoring the potential for human error in space missions. What will we do if we need to send humans to the moon again? Yes, you are right. We will work with legacy code. Yes, next great example. NASA loses contact with the Voyager 2 spacecraft after a mildly embarrassing case of human error. How many engineers who started the project still work on the code now? Interesting questions. It seems legacy code is everywhere, right? Okay, now let's move from space systems to our daily life. Surprises. Many banks, stock exchanges, and the IRS still use COBOL. But the COBOL programming language was invented in 1960 in the Department of Defense. How many engineers know COBOL now? Do we need to motivate junior programmers to learn COBOL? Yeah, even more. Oh, many power plants, electrical grids, and electrical control units still use Fortran. Anyone interested in learning Fortran now? Tricky questions, right? That's not all. You will be surprised. 83% of medical devices run on outdated operating systems, according to the HIPAA Journal 2020. The most critical systems work on old operating systems? Really? What about the most critical systems in the world? US nuclear weapon systems worked on floppy disks until 2019. Oh my God, legacy is everywhere. Well, guys, what will we do with all these legacy codes and legacy systems? Okay, let's analyze what kind of obsolete code and systems we have. First of all, we need to find out if our hardware is outdated, computation systems, and data storage systems. Is our operating system outdated? Good question. The same goes for programming languages, frameworks, and even software paradigms. And is our testing process obsolete? What about the running environment? There are some advantages to keeping legacy code unchanged. Yeah, you can see all these advantages on the current slide. Okay, but we need to teach junior developers to learn outdated programming languages and tools. Oh, even motivate manufacturers somehow to produce old hardware. Remember when NASA bought old x86 processors from people because they were no longer in production? Yeah. Well, what is the impact of legacy code on business? We need to keep an eye on regulatory compliance. Yeah, as well as risk mitigation. Um, and of course, we need to minimize downtime. Sure. Next great question. Does an optimal strategy for legacy code exist? It seems we have some ways to manage this. Well, here on the slide, you can see the necessary steps to complete for making your code up to date with modern technologies. Let me highlight two of them. First, incremental modernization. Never solve a big problem all at once. Try to decompose the task. Second, use a hybrid approach. Combine refactoring and rebuilding of the legacy source code. Well, as you understand, we will always need to make a choice, right? In this case, we need to choose between rebuilding and refactoring. In some cases, refactoring the code is not an option. Yeah, because if you transfer the code from COBOL to C++, it seems rebuilding is the only option. But if you work with legacy code within the same programming language and frameworks, then refactoring has some advantages. Do you agree? Now, let's talk about cost-benefit analysis. Okay, refactoring versus rebuilding, you must always consider business needs first. Second, technical considerations. For instance, do we have enough floppy disk factories to make this kind of storage device? Well, risk management. Always analyze the risks and create an anti-risk plan. Well, think about the risk. Is it safe to keep Fortran or COBOL code in your system, um, or do we have enough resources to rebuild the system? Okay. Okay, friends. This slide is probably a subject for the next seminar, right? In short, what tools will help us with legacy code management? There are some static code analysis tools like SonarQube and PMD. Also, refactoring automation tools like IntelliJ and Eclipse might be helpful. Of course, AI tools like Copilot, okay? In some cases, automatic translators from old-fashioned computer languages to modern ones, they do a great job. Um, like Fortran to C translators, they really help a lot. Well, containerization, of course, and microservice architecture helps to rebuild complex monolithic systems in some cases. Okay, great. Well, ahem. In some cases, using standards might be very helpful, like the POSIX standard or ANSI standards. The only problem is that these standards will become obsolete over time. But it will be easier to transfer the code to the new standard from the old one. This is because of the continuity of standards. They are compatible in some way. From experience, it is better to use standards than not use them. It will make the problem of transferring from legacy code easier. Okay, documentation for software systems. Well, please create the documentation if you make the software. Well, future generations will be very grateful to you for every single page of documentation. Yes, they will. So you can use documentation generators like JavaDoc and NDoc. Please use UML. It might be very helpful. Imagine you need to return to your project in 10 years. What kind of documentation would you want to have in this case? Use this strategy, it works. Okay, guys, the key problem for refactoring and rebuilding old code is testing. Well, very often we cannot reproduce all necessary test cases for replacing old software. First of all, because of a lack of test documentation. And of course, some undocumented behavior may be present. So testing is key for the replacement of legacy code. Great. What future trends will we have for legacy code management? AI, artificial intelligence will be very helpful in the next 2 to 5 years for helping us with legacy code management. The potential of AI with source code is not fully discovered yet, right? Also, we have very big potential with DevOps and cloud systems. It'll be great to see more tools and methods to help us with legacy systems. Cloud migration is very strong now, but we will see more technologies here as well. Okay, key strategies and practices to effectively handle legacy code. First, assess your legacy systems. Identify and prioritize updates based on business needs and the urgency of technical debt. Adopt a hybrid approach that combines refactoring and rebuilding. This allows for gradual improvements, minimizing risk and disruption. Yeah. Involve stakeholders in planning for training and knowledge transfer. This ensures continuity and support throughout the process. Focus on test automation to maintain continuous integration and deployment. This ensures reliability without slowing down the development process. Well, use modern tools like static code analyzers, automated refactoring tools, and containerization techniques to boost efficiency and productivity. Yeah. Um, Keep thorough documentation using self-documenting code and documentation generators. This helps future maintenance and smooth transitions. This approach ensures a smooth modernization journey with minimal risk and disruption. Well, next slides. Let's take a look at what kind of resources we have for learning how to work with legacy code. Um, the um, um, the amazing book here is Working Effectively with Legacy Code by Michael Feathers. Special thanks to the author for this great book. It really saves a lot of time for developers and makes our lives easier with legacy code. Many, many thanks to Mr. Feathers. Another great book from a great author. Special thanks to Dr. Martin Fowler for his book, Refactoring, Improving the Design of Existing Code. One more great book. We should be very appreciative to Robert C. Martin for his excellent book, Clean Code, A Handbook of Agile Software Craftsmanship. Thank you very much, Mr. Martin. Another great resource. Please take a look at the video from Dennis Duman, Tools and Practices to Help You Deal with Legacy Code. It was presented at the NDC Porto 2023 conference. Also, it is recommended to take the course Refactoring Legacy Code like a pro, a use case. Please note that this course is language agnostic. It means it can be used with any programming language. Svitla Systems helps a lot of companies with legacy technologies, right? This includes legacy system assessment. Also, we do re-engineering and refactoring to optimize and modernize your code base. Our team provides seamless integration of legacy systems, and we do incremental modernization. Of course, we pay attention to minimizing risk and ensuring business continuity. On this slide, you can see Svitla Systems success stories with legacy code. These 4 cases are a small part of the many projects with legacy code we did. We had cases with old legacy hardware, including outdated microcontrollers. Many times we helped companies transfer their projects from outdated code bases and programming languages to modern ones. This includes cases from different industries, such as finance, transportation, e-commerce, etc. Also, we did a lot of transitions from monolith architecture to microservices. Well, guys, in conclusion, managing legacy code is not easy, but it can be done. Legacy systems often embody crucial business logic, but it comes with risks, outdated hardware, software, and, methodologies. Please contact Svitla Systems to schedule a consultation. Discover how we can help you transform your legacy systems. Thank you very much for your attention. Please ask your questions. Konstantin will be glad to answer them. Thank you very much.